Hi everyone, welcome to Deeksha Karnataka. I am Deeksha Kaushal, your chemistry master teacher. So everybody do let me know in the chat box if I am clearly visible and audible to all of you. Very good afternoon students, very good afternoon. So do let me know if I am clearly audible and visible to all of you or not. Everybody in the chat box, do let me know. Just give me a second. Yes. Okay. Yes. Yes, good afternoon, students. So, today we are going to talk about chemical bonding. So, I'm going to teach you, like, chemical bonding is that chapter from where, like, in NEET, definitely you will see 2 to 3 questions in your exam. Definitely, that is 100% sure. Right? Now, in chemical bonding, right, there are some topics which are like very important. First is calculation of hybridization. They will give you random. Now, this is a very famous question of chemical bonding. They will give you some compound and they will ask you what is the hybridization, what is the shape, what is the geometry of that, right? Based on this, they also ask you calculate the number of lone pairs, and this is based on the same thing, right? The steps are going to remain the same, right? So first we will discuss about this thing, then we will discuss about second important topic, that is MOT, molecular orbital theory, and we are going to do questions on it, neat PYQs on it, right? And the last one, the third topic is dipole moment, and the last one is bond angle. These are the 4 topics majorly from where they ask you questions from chemical bonding. So let's start this without wasting any time. Right, everybody? Let's start this without wasting any time. Yes, everyone? Tell me, why so less students out there? How do I teach? Huh? Chalo. So let's start, okay? Now, when I talk about chemical bonding here, right, first topic is formal charge. If we talk about formal charge, that means in a compound, right, one single atom has how much charge. So when we talk about the formal charge of any atom, how do we calculate it? Number of valence electrons of the atom in free state. Let's say I'm talking about oxygen, right? In the oxygen, how many valence electrons are there? Valence electron means in the outermost shell, how many electrons are there? Now, if I talk about oxygen, it belongs to group number 16. That means Ns2Np4 it is. So valence electron, you can see it is 6 valence electrons, right? Now, if I talk, okay, now one more thing here. When I talk about oxygen, it is 1s2, 2s2, 2p. This is actually atomic number is 8. So 4, it will be 4. So this is the outermost shell. I am not talking about the subshell. I am talking about the shell here, right? So that's why I'll just tell you one more thing here, right? That is, when I connect these things here, let's say this is group number 1, this is 2, this is 13, 14, 15, 16, 17, and 18. Now, 2 things we'll talk about. One is the valence electrons, other is the valency, right? If I say valency, because both the things will be important for you, and here we have valence electrons. Now, valence electrons, in this case, if you see the electronic configuration here, this is going to be ns1, this is ns2, this is ns2np1, this is ns2np2, this is ns2np3, okay, this is ns2np4, this is ns2np5, this is ns2np6, right? That is going to be the overall configuration here. So if you see this here, the valency is going to be Valency. Firstly, we'll talk about valence electrons. How many outermost electrons are there? Here you have 1, here you have 2, here you have total 3, here you have total 4, here this is 3 plus 2, 5, right? This is 4 plus this 6, this is 7, and this is 8. So the valence electrons are the number of electrons that you have here: 8, 7, 6, 5, 4, 3. These are the valence electrons. Now, if I see the valency here, what is the valency? Valency means the number of electron gained or lost to be in a fully octet state, where it is having the octet state. So here it will lose 1 electron. So valency will be 1. It will lose 2 electrons here. So valency will be 2 here. Here it is going to lose 1 electron, right? Okay, only then it will be Ns2. Then here it is going to lose 2 electrons. Here it is going to lose 3 electrons, right? Then here it is going to gain. Here it will gain or lose both of them, right? So here it is 16 now. This was 14. Wait a minute. Valency, so we have seen. Here it is N4, so it is going to gain 2 electrons. Here it is going to gain 1 electron. Here no electrons it will gain, right? Okay. Accordingly, you have. That is why this is group 1, group 2. Usually it is not asked, so you can skip this. But this one is important for you. Now in this chapter, most important is to know the valence electrons. This one will be most useful for you, right? So when I say some element, like if I say chlorine, you know chlorine belongs to group number 17, you will say 7 valence electron. If I say sulfur, you know sulfur belongs to group number 16, so it has 6 valence electrons. If I say fluorine, tell me how many valence electron? Fluorine belongs to group number 17, so it has 7 valence 17, so it has 7 valence electrons, right? So valence electron, if I say boron, it belongs to group number 13, so 3 valence electrons. So that should be on your tips. Like you just see the element and you don't need to all of these things. That should be on your tips. What is the valence electron? So number of valence electron of that atom minus number of unshared electron, maybe lone pair are there or any negative charge is there, minus half number of shared electron, half number of shared bond pair electrons, right? Now let's talk about how to solve this, what exactly we want to do here. For that, I'll give you one question here and we'll solve it this way. This is a question and they are asking you. From the question, we'll understand that what exactly is there. Okay, right? Okay, yes. Ouch. I was about to fall now. Okay, so if you see this is nitrogen, they are asking you to calculate the valence electron on this oxygen, on this nitrogen, on this oxygen and on this oxygen. Let's talk about this one by one. If I talk about the first one here, for the first one, this is oxygen, right? In oxygen, it belongs to group number 16, so 6 valence electrons, right? So I'll say minus lone pair. How many lone pairs? 1 and 2, right? And they are asking about lone pairs only. If you see number of unshared electrons here, right? So number of unshared electrons is 1, 2, 3, 4. So you can say minus 4 minus half, and half, that means divided by 2. How many bond pair electrons? 1, 2, 3, 4. 4 bond pair electrons. So it will be 6 minus 4 minus 2, that is going to be 0 here, right? So in this, the formal charge is going to be 0. This oxygen is going to be neutral. That is on first, right? What about second? Let's talk about second here. Second is nitrogen. Nitrogen is belonging to group number 15. So 5 valence electrons it will have. So we'll write 5 here, right? Minus number of unshared electron. Is there any unshared electron? There is no lone pair here, right? Minus 0. Minus bond pair divided by 2. Bond pair electrons are how many? 1, 2, 3, 4, 5, 6, 7, 8. 8 by 2 is 4, right? 5 minus 4 is 1 here, right? So it is going to be a +1 charge. That means here you will have one positive charge, right? Okay, now let's talk about the third atom here, that is oxygen again. Now on the third atom it is oxygen, so number of valence electron in oxygen, oxygen belongs to group number 16. So it has 6 valence electrons, so you will write 6 here, right? Minus number of unshared electron, 1, 2, 3, 4, so -4. Minus bond pair electron, 1, 2, 3, 4. 4 divided by 2 is 2 only. So we can say this will also cancel out and answer will be 0. So this oxygen also have 0. I'll also give you a trick for this one, right? So fourth is this one, but you should always know to calculate it from the formula. Trick I'll give you for nitrogen and oxygen, right? So from the fourth here, again oxygen, that means 6 valence electrons, minus unshared electron is 1, 2, 3, 4, 5, 6, right? Minus bond pair is 1, 2, 2 by 2 is 1 here. So 6, 6, so answer is going to be -1. So this is having -1 charge, this is having +1. This is 0 and this is also 0. That is going to be the answer. So 0 plus 1, 0 minus 1. 0 plus 1, 0 minus 1. So answer is C is the correct answer here. Got it? Yes, everybody. Now a simple thing I'll tell you here that you must know. I'll just tell you this here only to, save the pages of notes, right? Because more pages, aha, man, very difficult, isn't it? Okay, so see this thing. Now, see oxygen always wants to form two bonds. In a normal life, oxygen is saying that I want to have two bonds, right? If let's say, and in the normal life, nitrogen wants to have how many bonds? Nitrogen is like, in the normal life, I want to have 3 bonds. This is a simple trick with which you don't need to do it for nitrogen and oxygen, but otherwise you should know the formula of formal charge. See, whenever, let's say you were expecting 90% marks and you got 95% marks, you will be super happy. Positivity will be all around, isn't it? Same thing. You was expecting 2 bonds, but whenever oxygen has 3 bonds, then the charge will be positive. He was expecting 2 bonds. Now, whenever you were expecting 90% marks, you got 85% marks, will be sad here, right? So, when he got only 1 bond, negative charge will be there, okay? Similarly, for nitrogen, you were expecting 3 bonds and suddenly the number of bonds are more than that, that is 4. That means here positive charge will be there. And you were expecting less bond, you were expecting 3 bonds, you got only 2 bonds, so that is why here you will have the negative charge here. This is what we want to say when we talk about the positive and negative formal charge for nitrogen and oxygen. Tell me, is that clear to everybody or not? Right, everyone? Now, let's talk about the hybridization. For hybridization, firstly we'll understand how to calculate for any compound that is given to you. Any compound. How do you calculate the steric number? Because once you know the steric number, only then you will know the hybridization. And from the hybridization, you will get to know about the geometry here. So first and foremost thing for us is to understand that how to calculate the steric number here. To calculate the steric number, we have this formula, right? Okay, we have this formula that we will apply everywhere to understand this thing, right? Okay, now see, the formula says number of hybrid orbitals is equals to half total number of valence electron in the central metal atom, right? So central metal atom can be like nitrogen, oxygen, like in water, H2O. Sentimental atom is oxygen, the one that has more electronegativity and is less in number. That is the sentimental atom, right? Number of valence electrons divided by 2 plus total number of monovalent atom divided by 2. How many? Monovalent atoms can be either hydrogen or halogen, right? That means which has valency 1. Hydrogen has valency 1, and you have also metals of group number 1 also have valency 1. But usually you will not have group number 1 metals, so that is why I am just writing hydrogen and halogen, right? Minus charge on cation. If there is cation, charge will be subtracted. If there is anion, charge will be added here, right? Now let's talk about this thing here, right? One by one we'll talk about this, but this we'll talk about later on. Firstly, let's talk about how to calculate it, right? So one by one I'll go through it, and this is trust me, if you see this very carefully, you will be able to do this, right? Okay. Neha, I don't know, you're always there in my sessions, but I'm very strictly and very sweetly telling you one thing, right? That don't distract me or any of the student that is sitting here, right? So please focus, right? So now, if you see, I'll tell you now, no, I'm not going to tell all these things, okay guys, so lone pair is 0, bond pair is 2. See, that you know that if lone pair is 0, bond pair is 2, then what is steric number? This steric number has a formula. This steric number, that is sigma, is going, this steric number, you can represent it by Z. This Z is going to be sigma plus lone pair always, right? Now, if they have given you how many sigma and lone pairs are there, lone pair is 0, sigma bond is 2, so answer will be 2 plus 0. The steric number is 2 here. Here also 1 plus 1, the steric number is 2 here. Steric number is 2 here as well, here as well. And whenever the steric number is 2, we say it is a sp hybridization, right? Then if I say it is a sp hybridization, I can write it here, it is sp hybridization, it is sp hybridization, right? In sp hybridization, obviously the structure is going to be linear, it is going to be a linear geometry, right? Or you can say just structure, this is geometry is going to be linear here. Now, so many things I'm going to tell you, just wait. Now, if I see this is A, this is B, and this is B, it is going to be a linear structure like this. Okay? Wait a minute, let me just tell you. It is going to be a linear structure like this. Like this, it is going to be a linear structure. Now, remember one thing, bacha, always, this na, I'll just put it somewhere else. We don't need it here, right? We'll talk about this. Aha, this is actually we need it here only. Yeah, wait a minute. Yeah. So now let's come to this thing. Whenever you have lone pair, geometry will remain the same. Geometry will be equals to, if it is sp hybridization, geometry will be linear only, right? But here what will happen, one bond is there and one lone pair is there, right? So that is why the structure has changed a bit. In this, you can see this is also linear, this is also linear. Here though it is same only, linear. Here also it is linear, here also it is linear. That is not a big thing, right? But what happens, I'll tell you this later on here, because this is also not important for you, so I can just delete it here. This is just a reference that I told you, right? Otherwise, this is not important. We'll talk about that whenever, right, I talk about shape, I am only talking about the bond pairs. Whenever I am talking about geometry, I am talking about lone pair plus bond pair. That means in this case, there is 0 lone pair. That means 0 lone pair means geometry and shape is going to remain the same. So you can say when lone pair is 0, geometry and shape are same. Geometry is equals to the shape. But later on we'll see when the lone pair is 1 or 2, then the shape will change, because in the shape we don't see we don't see lone pair, we only see bond pair. I'll tell you this, right? For that you have to wait a bit. But now let's talk about this thing here, right? Okay, what I am telling you here. For example, lone pair is 0. I am telling that bond pair is 3. Okay, lone pair is 0. This is 3. So overall it is 3. Overall the steric number is 3, right? Here overall 2 plus this is 3. Here 2 plus 1 is 3, right? Now whenever you have 3, whenever Z is equals to 3, it is going to be sp2 hybridization. Okay, so hybridization, whenever steric number is same, it is always the same, that is sp2. Now sp2 hybridization has this kind of geometry which is trigonal planar. Okay, let me just draw one trigonal planar structure here, right? This is the trigonal planar structure, as you can see, right? In one plane, a triangle it is forming, right? Now, if you see this here, it is a trigonal planar structure. Geometry always, geometry we talk about bond pair plus lone pair. Geometry always will remain trigonal planar, trigonal planar, trigonal planar, right? Here also trigonal planar, that is not changing. Now see this thing. What you will have here is, you will have one bond pair if all the three are bond pairs. Okay, if I am saying all of these three are bond pairs, this is going to be the shape, because in shape I talk about only the bond pairs. So 3 bond pairs are there, this is going to be the shape. If I say one of them is lone pair, lone pair means, let's say I am giving lone pair by this green thing is the lone pair. Okay, if I say there is one lone pair here, right? And while calculating the shape, see, when you see the geometry, you calculate lone pair, bond pair both, it is again trigonal planar only. When we see the shape, we only see bond pairs. Now it is not trigonal planar, now it is bent V shape. Okay, that is why we say that when we see this thing here, here the shape is trigonal planar only, trigonal planar only, because in shape we only look for bond pair, and this is becoming bent V shape, right? So you can say this is bent V shape. And remember, always whenever you have only one bond pair, here also when you had only one bond pair, it was, if you see this here, here also when it was one lone pair, one bond pair, always it was linear only. That's why I'm going to erase it in every single thing, because one bond pair means always linear will be there, no matter what is the hybridization, what is the geometry, right? Because one bond pair, if there is only one bond pair, there is not even a concept that some other shape it can give, right? Okay, yes everyone. Now the next question that arises, right, in our head, yeah, we'll talk about bond angles as well. Next question that arises in our head, ma'am, how do I understand that this has 0 bond, lone pair and 2 bond pair? In the exam, ma'am, they don't give us lone pair, bond pair, they only give us BeCl2. How do I understand in the exam that this is which one? Okay, so for that now we'll see how to apply this in the exam. See, you have BeCl2. Firstly, you will see the central metal atom, that is beryllium, right? Beryllium belongs to group number 2. So hydrogen, helium, lithium, beryllium, hydrogen, helium, lithium, beryllium, boron. Beryllium is 1s2, 2s2, that means 2 outermost electron, 2 valence electrons. Group number 2 means 2 valence electrons. Now, it will be half 2 valence electrons. Any monovalent? 2 monovalent. Any positive negative charge? No. Right? So if you see 2 and 2 cancel here. Am I doing it right? Wait a minute. Let me just see the formula. Right? Half into total valence electrons, total number of monovalent minus charge. Yes. Okay. So here if you see, right, in this case, hydrogen, helium, lithium, beryllium. 1s to 2s2. Wait a minute. Wait a minute. 1, 2, 3, 4. Right? Ha. Okay. So yeah, I'm so sorry. Yeah. What we are doing here is another thing. Wait a minute. So if you see, wait a minute. Something number of valence electron in centimeter, total number of monovalent plus now why I was thinking that what I have done wrong. Yeah, okay, so it was plus here. Okay, so it was 4 by 2, that is 2. 2 means now we got to know that it is overall steric number is 2, right? Steric number you will calculate from the formula, right? But ma'am, now we just have steric number. Ma'am, we still don't know how many lone pair bond pairs. So how do you calculate the lone pair bond pair? You will simply write here that BeCl2. BeCl2 means this is going to be the situation. Even if I don't know, even if I have no idea about the shape, I can still say that 2 bonds will be formed here because in the formula it is BeCl2, right? That means here what will happen, you will have 2 bond pairs, right? Overall you have 2 is the valence electron, and out of those 2 valence electrons are busy in making bond pairs. That means there is 0 lone pair that is available here, right? Okay, that's how you write it. You say 2 valence electrons, 2 valence electrons and 2 bond pair. So what is exactly lone pair? Lone pair also you can write the formula here. Lone pair is equals to valence electrons minus bond pair. Minus bond pair. Right? So valence electron is 2, bond pair is 2, answer will be 0 here. That is why lone pair is 0. We can say that sigma plus bond pair. Sigma is what? How many sigma bonds? Sigma bonds are 2 as you can see here. Right? And sigma plus lone pair here. Okay? Sigma is 2, lone pair is 0, so answer is 2. That's why we say that sigma is 2. Sigma is 2, lone pair is 0, right? Overall it is 2, it is trigonal, it is 2, that means it is going to be a linear structure, that is VeCl2. Now I am teaching you very, very slowly here so that you get to know what I am doing here, right? Now let's be fast, right? This is BF3 and SO2, right? So I'm going to calculate it for BF3 and SO2. Let's do that, right? Now you have 2 structures here, right? These are very, very famous structures. In the questions, I don't even need to solve it because so much things we'll do here. Now, I'll tell you something. I don't even calculate it from the formula. I do it in another way. I'll teach you that. So, firstly, we'll talk about BF3. Okay, this is SO2. Firstly, what you do, make a like rough structure of it. BF3 means boron with 3 single bonds because fluorine always forms sigma bonds. Now oxygen form multiple bonds. So always this is going to form this kind of bond. This is a rough structure that I have drawn. I have no idea what is the structure. I have drawn a rough structure. Right now see. Calculate Z first. What is Z? Z is half into, here boron belongs to group number 13, 3 valence, plus number of monovalent is 3, no negative positive charge, so overall it is going to be 3. 3 means it is sp2 hybridization, right? Now how many lone pairs are here? Lone pair is how many sigma bonds? 3 sigma bonds are there. And how many bond pairs? Sigma bonds are 3, right? And here if you see sigma bonds are 3, right? Okay, you can also do one thing here, okay? I'll tell you a better way here. Lone pairs, you can also calculate it like steric factor minus steric factor, you can just write it here like this also. Wait a minute. That will be much easier for you. Just by writing only, I got to know that this is also a better way to write it, right? Lone pair, you can also calculate it by lone pair is equals to steric factor minus bond pair, right? So steric factor is 2, bond pair is 2, it is going to be 0. So here also you can do it this way. Lone pair is equals to steric factor minus bond pair. Steric factor is 3 that we have calculated. Bond pair, 3 sigma bonds it is forming. And whenever I say bond pair, that means I am talking about both sigma and pi bonds, right? Because out of the Z, all of them it is forming, right? So overall it is 3. Now if you see, now see one thing, that overall if I say that lone pair here is going to be, overall in this you had 3 valence electron and all the 3 valence electrons are occupied here. That means I can say 0 lone pair. So sigma plus lone pair, sigma is 3 and lone pair is 0, so overall it is 3. Okay? So that's what I wanted to tell you. You just need to see the lone pair here, right? This is just by in the end we are doing it for our reference, that okay, we have calculated Z as correct. Now it is 0 lone pair. That means this sp2 means trigonal planar. All of them are sigma bonds only. So this is going to be the structure. Now let's do it even more faster, right? How you can do it even more faster in the exam. Z is equals to, sulfur belongs to group number 16. So 6 valence electrons. How many monovalent? No monovalent, right? No negative positive charge. So this 6 by 2, that is 3, that is sp2 hybridization. That means it is definitely trigonal planar, that we know. Okay. Acha, now see one more thing. If I say the lone pair, overall sulfur has 6 valence electrons. Out of that, 1, 2, 3, 4. 4 it is using. That means 2 are unshared electrons. That means 2 unshared electron means in the lone pair the unshared electron are 2. That means lone pair will be 2 by 2, that is 1. 2 unshared electron means 1 lone pair, na? So that means here we can see the lone pair is 1. I'll do it again. See what I have done here. See what I have done here. I'll do it again. See how I did it, because I am going to now solve the questions just like that. Okay, lone pair, how I did, I solved it. I said sulfur has 6 electrons to share. Out of that, 4 are already occupied. That means 2 electrons are left. That means lone pair is going to be 1. So in the end you have, out of this 3, 2 are bond pair, 2 are sigma bond, 2 sigma plus 1 lone pair is there. That means the overall shape is going to be, this is sulfur, this is 1 lone pair, this is double bond O, double bond O. So here that is why it has trigonal planar geometry, but shape is bent V. But shape is bent V, and they usually ask you the shape in the exam, right? And that's why we have written it like this. Structure I have already drawn for you. Now let's talk about the next thing here. Let's talk about the next thing, guys. Next is, let's talk further. When the steric number is 4, when the steric number is 4, then we say that it has sp3 hybridization. Steric number is 4, it is said to be sp3 hybridization. That means it is said to be tetrahedral in nature. Okay, it is said to be tetrahedral in nature. Acha, now see this thing. If I say, ma'am, lone pair, bond pair, this is 4 plus 0, 4, 3 plus 1, 4, 2 plus 2, 4, perfect. But ma'am, in the exam, only the formulas will be given to you. So let's talk about how do we solve it directly, right? So let's solve it directly for the exam purpose. So I'll just divide it into 3 parts because we have 3 structures here, right? What are these 3 structures? And let's solve one by one, okay? So structure number 1 is CH4, then NH3, then H2O. So you have CH4 here, then you have NH3 here, then you have H2O here, right? Till now, you have no idea how many lone pair, bond pairs are there, right? Okay, now let's see. See this thing. Calculate steric number, Z is equals to half. This is Carbon belongs to group number 14, so it has 4 valence electron plus 4 monovalent, no positive negative charge, so answer will be 4, that is sp3 hybridization. Here also Z is equals to, here you have half, number of valence electron is 5, 3 monovalent, 5 plus 3 is 8 by 2 is 4, that is sp3 hybridization. Okay. Acha, here also same thing, Z I am calculating half, number of valence electron of Cm means centimetal atom is oxygen, oxygen belongs to group number 16, 16 means 6 valence electrons, right? Plus monovalent is 2, 6 plus 2 is 8 by 2 is 4, that is sp3 hybridization till now. Acha, now we are doing it, we are going to do it further, okay? This is sp3, 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 that is perfect, great. Acha, now let's see. Lone pair calculation. Lone pair is, here carbon has 4 valence electrons. Out of that, it is using 4 sigma bonds it is forming. Right? Sigma or pi bonds, whatever it is forming. We are talking about sigma plus pi bonds, how many it is forming. So 4 minus 4, 0 lone pair. Here, valence electrons are 5. 3 bonds it is forming here with hydrogen. So answer will be 2. So lone pair is 2 by 2, that is 1. That means 1 lone pair is there, right? Acha. Here valence electrons are how many? 6. Out of that 2 bond it is forming. So 4 by 2, that is 4 by 2 is 2. So here lone pair is 1, here lone pair is 2, and here lone pair is 0. So now we know it is going to be tetrahedral only, and how tetrahedral geometry looks like. It looks like this, okay? Now firstly see how tetrahedral geometry looks like. It looks like this. It has an angle of 1, 0. Now if I see trigonal planar, we forgot to mention trigonal planar. Trigonal planar will have an angle of 120 degree, right? So tetrahedral sp3 hybridization will have an angle of 109 degrees, 24 minutes, right? Now, what I'll do, if I say all of them are this, so in 3D how we draw it, this is CH, this, in 2D we draw it like this, in 3D it looks like this, 109 degrees. So you can say 109 degrees here, right? Now here I am saying 1 will be the lone pair. Now the lone pair in the shape, see all of them will have tetrahedral shape only. Geometry will be, tetrahedral only, right? Geometry will remain same, hybridization also will remain same, right? Difference will be in the shape. This is tetrahedral only, but NH3 which has 1 lone pair and other 3 are bond pair. Right now you might not see that what is this, ma'am. If I remove 1 bond pair and take it as a lone pair, this will become like this. Can you see? What is this? It is not a plane. If you see it from here, it is not a plane. I don't know if you're able to see this or not. This is bulge out, okay? This is not a plane. This may look like this. You will see it is trigonal planar. It is not a plane. Trigonal planar is looking like this. Trigonal planar looks like this. If you see it. Now that is the difference. This is little bit bulge out. There is no bulge out here, right? This is bulge out, if you can see this here, right? And here there is no bulge out. So this is trigonal pyramidal. Thank you, Shushant. So this is pyramidal, okay? Shape will change, pyramidal shape. You don't have to see in the shape, don't see the lone pairs, okay? Acha, now let's talk about water. In water, earlier you had 2 lone pairs here, in tetrahedral. Now you will take out 2 lone pairs, okay? Now it will be a bent V shape. So that is why for water we say it is a bent V shape. Water looks like this. This is oxygen. This is 2 lone pairs. This is H. This is H. This you can also see. Just ignore this. You will see a bent V shape here. Bent V shape. Geometry is tetrahedral in all these 3 cases. Hybridization is sp3 only, but shapes are different. Okay? Yes. Done. Okay. Chalo, now let's talk about the next one. That is when we say Total is 5. 5, 5, 5, 5. But ma'am, still please tell us, ma'am, how do we answer it in the exam? Will you do it along with me? Tell me. Will you do it along? I think I have done enough examples. I have solved enough examples for you. Now it's better you start doing it with me. Otherwise, you will not be able to do it in the exam. In the exam, I can't be with you in the exam sitting next to you. So you have to do it yourself. Right? Okay, let's do this. Acha. Now, wait a minute. Yes. So, we'll do this. Again, I'll take all, these are all important structures only. We'll take it. PCl5, SF4 and ClF3. Very important, highly important structures. Okay. Now see one thing. PCl3, PCl5, then you have SF4, then you have ClF3. Okay. But see one thing, that whenever the steric number is 5, it is sp3d hybridization, and that means always the geometry is going to be trigonal bipyramidal. Okay, just not written it right. Trigonal bipyramidal. You know how the geometry looks like? It looks like this. If you see, there is this triangle that is moving, trigonal. This is upper pyramid, this is lower pyramid. So trigonal bi means two pyramids. Okay. So now we'll see one by one how to do it throughout the exam. So firstly, again, same thing I am doing again and again. Z is half. Phosphorus belongs to group number 15, means 5 outermost electrons. Monovalent are 5. No negative positive charge. Overall 5. It is sp3d hybridization. That means trigonal bipyramidal geometry. Again here Z is equals to half. Sulfur belongs to group number 16. That means 6 outermost electrons. 4 monovalent here. Halogen is monovalent. Right? No positive negative charge. 10 by 2 is 5. That means again sp3d. Okay. Achha, now let's see this. Z is equals to half. Again, chlorine is halogen. Halogen has 7 outermost electrons, 7 valence electrons, plus 3 monovalent. 7 plus 3, 10 by 2 is 5. That is sp3d. Now it is clear that why it is always sp3d hybridization. Why geometry is always trigonal bipyramidal. Now let's talk about the lone pairs here. How do you calculate the lone pair, bacha? Tell me everyone. Lone pair will be calculated by, you will see, phosphorus 15 means, group number 15 means 5 valence electrons. Out of that 5 bonds it is forming, so 0 lone pair. Here lone pair, sulfur is 16, so 6 outermost electrons. And it is forming 4 bonds here, that means 2 electrons. 2 electron means 2 by 2 means 1 lone pair. Right? Because 2 electron means 1 lone pair. Acha, here lone pair is, chlorine has 7 valence electrons, 3 bonds it is forming, 7 minus 3, 4 by 2 is 2 lone pair. Now see, here the geometry will remain the same. Geometry will be P1Cl, 1Cl, 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 1Cl. Okay? Here you don't have any bond pair. So I am saying 3Cl over here and 1Cl above, 1Cl down. What about this one? This is sulfur, right? In the sulfur, there is one lone pair, but now the question is, should lone pair be on this position? Because now you have this kind of shape. Or should lone pair be on this position? Now you have this kind of shape. Now see, this is one very famous question of Neet, right? Which these positions, this up and down position, these two positions that I am marking here, this up one and this down one, this is called as, that means this position and this position, it is called as axial position. And this one that I am rotating here, that is called as, this one that I am rotating, can you see me rotating this position? That is called as equatorial. That means this and this is called as equatorial. And always lone pair are placed on equatorial position, right? Always lone pair are placed at equatorial position, always, right? Okay, always it will be placed at equatorial position. Reason being, at this position, they can also ask you reason in assertion reasoning questions. This lone pair here, this lone pair here, this lone pair here have 120-degree angle with each other. They all have 120-degree angle. This has 190-degree here and 190-degree here. Okay, so if you place lone pair here, repulsions will be to this 90 and this 90 more, because 120 degrees is a wide angle as compared to 90. If you place lone pair here, it is 90-degree to this one and this one. So 390-degree repulsion. So more repulsion means less stability. That is why lone pair is always placed on equatorial position. And if you see, this is a very famous shape. If you place it here, this looks like a seesaw, right? This looks like a seesaw. So it's a seesaw shape. That is why very famous shape, seesaw shape, right? What about this one? Here two lone pairs you will have. Take two lone pairs. It is a T shape, as you can see, right? So here it will be written as two lone pairs here. See, all, even if you put lone pair here, it might look like this, right? So sometimes students say, ma'am, fluorine is here, lone pair is here, ma'am, fluorine here. Ma'am, this is a wrong structure. No, this is also a correct structure, because these three positions are equatorial position, right? In 2D it may look like weird, but any position you place lone pair, that will be equivalent only, right? Okay. Okay. Chal. Now let's see this. F, F and F. So that is why it is called as T shape, right? That is why it is called as T shape. Got it? Acha. Now let's see. Whenever steric number is 6, that means all of them are 6. So Z is equals to 6 means it is always sp3d2. It is always octahedral geometry. So hybridization always will be sp3d2. It is always going to be octahedral geometry, but shape will change. So we have three structures: SF4, SF6, BRF5. Let me just draw that. So you have SF6, right? BRF5, XCF4. Okay. Now see these things, right? Okay. Now, if you see this here, right, Z is going to be half into valence electrons is 6 plus 6 monovalent, that is going to be 6, that is sp3d2. This is Z is going to be half, bromine means 7 valence plus 5, that is 8 plus 4, again 12 by 2, that is 6, that is sp3d2, right? Acha. Now let's see, Z is equals to half. This is xenon has 8 valence plus 4, 12 by 2 is 6, that is sp3d2. Okay? Acha. Bilkul Neha Kumari, obviously it is there, right? So I think Neha is too much interested in chit chat and all. Neha, I really don't think so. You're interested in studying, right? I don't even know you're a girl or a boy out there, right? So, right, it's been 4 years I am teaching on YouTube online. So not 4 actually, 5 years, right? So I know, right? So stop all this, right? So I'll not entertain you, right? Okay. So if you see, this is sp3d2. Lone pair is going to be Lone pair is going to be how many valence electrons? 6. And here you have 6 bond pairs, that means 0. Here lone pair is going to be 7 valence minus 5 is already there. So 2 by 2, that is 1 lone pair, right? Here lone pair is going to be valence electron is 8. Out of that 4 is occupied in bond pair. So 4 by 2, that is 2. So now you have octahedral geometry that looks like this. This is the octahedral geometry. Okay, this is the octahedral geometry. In octahedral geometry, you have 90-degree angles with each other. All of them are at 90-degree angle with each other. Okay, so all of them are 90. This is 90, 90, 90, 90. Here also all of them are 90 degree. Now, if you place one lone pair, you will place it here. This will be the structure. Here you will place it like this, next to each other, like, oh sorry, opposite to each other to have minimum repulsions. Okay, so fluorine, 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 fluorine. Now you can see this. When you ignore this, when you take out any lone pair here, it will become square pyramidal, right? So you can say this is actually square pyramidal. Square pyramidal. Okay. What about this one? This is actually square planar. There is no pyramid. Square planar. Okay. Tell me. Tell me. Is that clear? Okay. Okay, yes. Now these are all the structures that I have already taught you, right? Now let's talk about the questions here. Let's see the questions, guys. First question here is, BF3 is planar and electron deficient compound, hybridization number of electrons in this. So BF3, I have solved it. I'm not going to solve it again because we have already done it while solving the when I was teaching you the concept here. You can see it has sp2 hybridization. It has trigonal planar geometry and shape, and there are 6 electrons that are completed here. So they are asking you hybridization, that is sp2, and there are 6 electrons overall that is being completed, 1 2 3 4 5 6. So answer will be D is the correct answer here. Right, now let's talk about the next question, that is Neet 2025 question. Usually these kind of questions are what they ask you in the exams. So 4 xenon compounds are given to you and they are asking you the geometry and shape, that means shape and hybridization of all of them. So let's talk about this, right? So one by one I'll solve it, right? So let me just divide it into 4 parts because we have 4 compounds to discuss, right? Okay. XCF2, you have XCOF4, then you have XCF6. Okay, now one by one I'll discuss all of them, right? See, Z is going to be half. Valence electron is, the xenon is noble gas, so 18 group, 8 electrons, minus how many monovalent? No monovalent, so it is going to be 8 only, no positive negative charge, so it is going to be 4, that is sp3 hybridization. So in sp3 hybridization, lone pair will be, valence electrons are 8 and it is going to xenon 1 2 3 4 5 6. So 6 bond pair it will be, that means 2 electrons will be left here, that means 1 lone pair will be there. So we can see this here that it is sp3 hybridization and here the structure is going to be like this. So it is going to be trigonal pyramidal structure, right? So you can say, you can take it here sp3 and it is trigonal pyramidal. They have given you only pyramidal, that also works fine. So you can say E is connected to 2 and for A2 I have these two, so these two are eliminated. Now B is for sure 1, we don't even need to solve it, but we will still solve it. C we need to calculate here. C means XCOF4. So I'll firstly calculate XCOF4. Z is half, this is 8 minus, now the rough structure is xenon will have 1 double bond, 4 single bond with fluorine. So overall 4 monovalent are there, right? No negative positive, 8 plus 4 is 12 by 2 is 6, that is sp3d2, right? Okay. Now the lone pair here. Lone pair will be, valence electron is 8, total 1, 2, 3, 4, 5, 6. 6 electrons are occupied, divided by 2 will be there, so it is 2 by 2 is 1 lone pair will be there. So in this case, it will have octahedral geometry with 1 lone pair, 1 double bond oxygen and 4 fluorine. That is square pyramidal. Square pyramidal. So in square pyramidal, sp3d2 will be the hybridization. So square pyramidal is this one. So C is going to be 4, right? C4 means this. So answer in the end is going to be C. Okay, right? Now let's talk about this thing. XEF2. Acha. XEF2, let's see. You have Z equals to half, 8 valence electrons, 2 monovalent, that is 8 plus 2, 10 by 2, that is 5. So it is sp3d hybridization. So you can just tick it here hybridization as well. Here it will be 1, right? And XCF6 also you can just tick the hybridization. If you see Z is equals to half, right? This will be 8 valence electron plus 6. 8 plus 6 is what? Wait a minute. 8 valence electrons plus 6 monovalent. There is no positive negative charge here. So 8 plus 4, 12, 13, 14, 40 minus 7 it will be. 7 will be sp3d3. So yes, we have one option, right? So here this is going to be sp3d3. Okay, but we'll still solve the shapes as well, okay, because you never know what they ask you in the exam. So lone pair is going to be 8 valence minus 2 are involved here, divided by 2, so 6 by 2 is 3 lone pair, right? Here 8 are there, 6 are involved by 2, that means 1 lone pair. See this thing, how we are going to do this. Xenon is sp3d, that means trigonal bipyramidal with 3 lone pair. 3 lone pair means 3 lone pair on the equatorial position and 2 fluorine. So it is overall a linear structure. But geometry is trigonal bipyramidal. Here it is distorted, this is xenon. 1 lone pair, what you will see will be here, right? And distorted octahedral it will be, right? 1, 2, 1, 2, 3, 4, it will be like this. So sp3d3 is a distorted octahedral position, right? So you can say distorted octahedral, right? Okay, tell me everyone if that is clear, right? Okay, so that I have already done. So answer will be C is the correct answer here. Now let's talk about the next question that was asked in 2024. Let's talk about this question here. Yes, students, the question says that you have, again the shapes they are asking, and I have done all the shapes here, so I'm not gonna do it, right? You can do it yourself. I have done it while solving the concept, right? We have seen what is the answer for F. This we saw it was it was square pyramidal. This was trigonal pyramidal. Yes, trigonal pyramidal. Tetrahedral was the geometry. XCF4 we have solved it. And this one was octahedral and this one was square planar. I have done it here. Okay, we have done it here. We have done BRF5 as well. We have done XCF4 as well. We have done SF6, 3 molecules, so we have done here only, right? One molecule we have done here, NH3, right? So we have done all of them. So that's why I told you that these are being directly repeated in your exam, right? So here A is 1, B is 4, C is 2 and D is 3. So answer will be A is the correct answer here, right? Okay. Now let's see the next question. Amongst the following, Acha, they are asking, see again, every year it is repeated, every year. There is no year in which they have not asked this question. Amongst the following, which one will have maximum lone pair electron repulsion? Okay. So, maximum lone pair electron repulsion. See in SF4 though you will have this lone pair here, this lone pair here. Maximum it will be like 180 degrees, right? Here it will have 180-degree angle difference, so that repulsions will be less here. Maximum lone pair repulsions we need. So here this cannot be the answer because 180, we need to have minimum angle here. In CLF3 now you will have two, we have solved it, two lone pairs were there and it was like this. And here lone pair repulsion was at 120-degree angle. Okay, 120 degree. IF5 I will solve it for you. XCF2 I think we have already done it. XCF2 I think we have just done it. It was this situation and three lone pairs which were at 120-degree angle, right? These were also at 120-degree angle. Wait a minute. But three lone pairs are there, right? Then this will also be eliminated because here if you see three lone pair with 120, that is going to be more as compared to that. Now let's solve IF5. IF5 I will solve it. If there is any new molecule, I will solve it for you. Now again Z is half. Iodine halogen means 7 valence plus 5, 7, 8, 9, 10, 11, 12. 12 by 2 is 6. 12 by 2 is 6. 6 is sp3d. 2 octahedral. Lone pair is total 7 valence minus 5 divided by 2. That means 1 lone pair. So I will have 1 lone pair and here it will have FF. So here lone pair electron repulsions are going to be minimum. First thing, the lone pair is only 1 lone pair is there here, right? So here you have only 1 lone pair, no lone pair repulsion. No lone pair repulsion. Because there is no other lone pair only, so this is also eliminated. So maximum will be D, which has 3 lone pair with 120-degree angle. Okay, so maximum will be here, right? So answer is going to be D is the correct answer here, right? Okay, tell me everybody. Now let's move to the next part here, that is MOT, molecular orbital theory, right? Tell me. Wait a minute. Okay, now let's talk about MOT, molecular orbital theory, right? So in molecular orbital theory, basically it was designed because why oxygen is paramagnetic, that we had no idea on. So that is why MOT was designed here, right? So MOT, it says that two atomic orbitals, they will combine together to form two molecular orbital, One will be anti-bonding and one will be bonding molecular orbital. Anti-bonding orbital is represented by the star and bonding molecular orbital is represented as it is. It is less stable and more energy. This is more stable and less energy, because energy and stability are inversely proportional to each other, right? It's a very simple theory. We say that, okay, let's say now a very important thing is when pz orbitals they combine to form molecular orbitals, they form sigma 2pz and sigma 2py. Okay, they overlap like this, lateral overlapping is there, right? But when we talk about 2px or 2py, they form pi 2px and pi 2py. That means you can see this over here. Wait a minute. What are the orbitals that you will have in this? So I'll just write here. You will have sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Then you will have sigma 2pz, sigma star 2pz. But in pi you will have py and px. So pi 2py, sigma pi star 2py, okay, pi 2px, pi star 2px. Okay, first thing you should remember this thing, that z is always sigma and x and y is pi. Okay. Acha. Now let's see another thing that you need to remember for your exam. That is, if you have less than 14 electrons, less than 14 electrons, in any molecule you have less than 14 electrons, right? Or you can say or equal, less than or equal to. Another is you have more than 14 electrons. The rule will be different here, okay? Less than 14 you will have set of 2, then one single, set of 2, then one single. So you will just remember it as 2 1 2 1, right? Some students also remember it as ba ba, right? Okay, so you can remember it as 2 1 2 1. More than it will be, you can see this here, 1 2 2 1. The set is 1. I think by mistake I have deleted it. It's 2 1 2 1. This is 1 2 2 1. Okay, this thing you must remember for your exam. Now I'll tell you how to apply it in the exam, right? For example, I have O2. Okay. O2 is how many electrons? O2 is 16 electrons. One oxygen has 8 electrons. So 2 oxygen will have 8 into 2, 16 electrons. 16 electrons. Now how you will fill it? More than 16 means you will follow this rule 1 2 1 2. So firstly 2 electrons in 1s, 2 electrons in sigma star 1s, in 2s, in sigma star 2s. So 8 electrons will always be filled in the same manner, and that is called as kk star, kk star. So this sigma 1 is sigma star 2 is sigma 1 is sigma star 1 is sigma 2 is sigma star 2 is. You don't even have to do it again and again. It is automatically done, right? So what I would suggest you, how to solve it in the exam. You have O2, that is 16 electrons. Just subtract 16 minus 8, 8 electrons. Now you have to fill 8 electrons according to 2 1 2 1 or 1 2 2 1. Now because bacha, this is more than 16, so you will mark it as 1 2 2 1. That means 1 2 2 1. So you will do it like 1 2 3 4 5 6 7 8. So you are left with 2 unpaired electron, and that is why O2 is paramagnetic in nature. Okay, Understood? Now I'll do it in the question form only, right? Let's talk about the question form only. The correct order of energies of molecular orbital of N2, how you will write it? N2 is 2023 question. See how you will do it. 14 electrons, right? 14 minus 8 is how many electrons? That is 6 electrons. So 6 electrons you have to fill. Equal means 2, 1, 2, 1. So you will fill 6 electrons. 1, 2, 3, 4, 5, 6. Okay? So order of energies. So sigma 1 is, sigma star 1 is, sigma 2 is, sigma star 2 is. Then it will be 2, 1, 2, 1. This is 1, 2. So this is eliminated. Sigma, sigma star, sigma this. Then this is 2p. 1, 2. Now, this is also eliminated. This will be 2, 1, 2, 1. This is also 2, 2, 1, 1. Again eliminated. So now I'll tell you how to represent this 2, 1, 2, 1. What do you mean? 2 always will be for 2px and 2py. So this is always 2px and this is 2py. Because they are pi, so you will write pi 2px, pi 2py. And the single, you know, there is a couple. There is always one couple in your class and this couple is 2px, 2py. There is one single person in your class, that is 2pz, who always wants to like stay single in class, right? So this is sigma 2pz. Now others, this one will be just anti-bonding of this. This will be pi star 2px, pi star 2py. This is sigma star 2pz, right? So answer is going to be, and this is also, there is no unpaired electron, so this is also diamagnetic in nature. Okay? So answer will be 2 is the correct answer here. That's how you write it. And the next thing is, guys, they ask you bond order here, right? So bond order is actually represented by, if you represent the bond order actually has a formula. Bonding molecular orbital, bonding electrons minus anti-bonding electrons divided by 2, or you can say number of electrons bonding, anti-bonding divided by 2. Okay. Now you don't have to do it again and again, because if I calculate the, for oxygen I did it now. Let's say for this, what will be the bond order, right? Bond order you want to calculate here. See, anti-bonding, see, always remember 1s and 1s will cancel, 2s and 2s will cancel. So you have to calculate them, right? For more than 8 electrons, you don't have to calculate. For this, how many anti-bonding? There is no anti-bonding, there is only bonding. So 6 minus 0 by 2, that is 3. So here bond order is 3. This you have to calculate, but directly the trick is, if the number of electrons are 14, it is going to be 3. For more than 14, just add 0.5 into, just subtract 0.5. For less than 14 as well, subtract 0.5. Like this is 3, this is 2.5, 2, 1.51. Right now, for example, I do it for oxygen. Let's say I am writing it for nitrogen. Nitrogen negative, nitrogen positive, then I am saying oxygen, O2, 2 negative. Now directly tell me the bond order for this one. For that, first you will see the electrons. N2 is 14 electrons, this is 15, 14 plus 1, this is 13 electrons, 14 minus 1, this is 16, right? This is 16 plus 2, that is 18. Now direct bond order is 18 means 1, 18 means 1, 16 means 2, okay? 13 means 2.5, okay? Then 15 means 2.5, right? Then 14 means 3. You directly have your answer of bond order. Okay, that is why MOT questions are quite easy to do, right? Okay, this we have done already. Now let's see another questions here. That is, which one of the following statement is incorrect related to MOT? So the pi star antibonding molecular orbital has node between the nuclei. Yeah, that is correct. They have node, that is correct. Anti-bonding have node. They are actually like this. If node is this thing, if you see this here, this is called as a node. The empty space between is called as node. So they do have node here, right? That is absolutely correct. In the formation of bonding molecule, the two electron waves of bonding atoms reinforce each other. Yeah, they will add on. Reinforce means they will get added up. That is also correct. Molecular orbital obtained from 2px in this obtain symmetrically around the axis. 2px and 2py, if you see, are they symmetrical? 2px and 2py around the axis, they are not symmetrical, right? If you see, right, they are not symmetrical. This is positive, this is negative. It is not symmetrical, right, around the axis, right? So that means this one is false here, right? Pi bonding or molecules orbital have larger electron density above and below the internuclear axis. A pi bonding molecular orbital has larger electron density above and below the internuclear axis. So this is based on the same things. This definitely have larger electron density as compared to this one. Okay. So answer will be C is the incorrect one. Okay. Next question is identify the molecule which does not exist only. Now, whenever the bond order is equals to 0, this molecule will not exist. Okay? Whenever the bond order will be equals to 0. So, helium is that molecule which H2, He2, it does not exist. I'll tell you how. This means hydrogen, helium. Helium has 2 electrons, so total 4 electrons. That means sigma 1s, sigma star 1s. Sigma 1s2, sigma star 1s2. So bond order is 2 minus 2 by 2, that is 0. So that is why this will not exist. So answer is D is the correct answer here. Right? Okay. Then guys, next thing to remember for your exam is they can ask you to calculate the bond order and they can ask you the order of bond length, right? So bond length is inversely proportional to bond order. Bond energy is directly proportional. Bond angle is directly proportional. Okay, let's talk about the next thing here, that is two statements are given to you. 2025 question, a hypothetical diatomic molecule with bond order 0 is quite stable. No, it is unstable. As bond order increases, bond length, both are false statements. Bond order increases, bond length decreases. This is not true. If the bond order is 0, that molecule will not exist only. It is so unstable. So both are false here. Both the statements 1 and 2 are false. So answer will be D is the correct answer here. Okay? Chal. Acha. Another question is related to diamagnetic paramagnetic character, and here also either you solve it thoroughly, just like I told you, this has unpaired electron, or you do it with the help of trick. So trick says that trick to classify any molecule as diamagnetic is odd number of electrons always will be para, even number will always be di. Okay, just remember ED. All remember OP, 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 OP. You write it in the exam, na? Not in the exam, you write it in the chat box. OP, 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 overpower, overpower, overpower. So OP, odd is always paramagnetic, right? But there are two exceptions. For boron, which has 10 electrons, for oxygen, which has 16 electrons. Now both of them are even. So even is supposed to be di, but these two are exceptions. They are para. Otherwise, this rule will be there in all the cases, right? Okay. So for example, you have this 18 electron, 10 electron, 13 electron, 16 that we have seen. 16 plus 2, 18, 10 electrons. This is 14 minus 1, 13. This is 16. This is even. Even is diamagnetic, or even is always diamagnetic. Okay? And here it is odd. Odd is always para. But 10 and 16 are the exception. This 10 will be 10 is even, it should be dia, but it is actually para because it is under exception. 16, oxygen, it should be, it is even, so it should be dia, but it is actually para. Okay. So that's how without even solving, you can directly tell in the exam. Okay. Let's see here. Let's see guys, wait a minute, this much so you don't even have to do. I'll just tell you this directly only. Which amongst the following is incorrect statement? If you see the bond orders of these are what? So just calculate the electrons here. It is 16 minus 1, 15. This is 16. This is 17. This is 18. 14 means 3. 15 means 2.5. 16 means 2. 17 means 1.5. This means 1. 2.5 to 1.51. That is absolutely correct. C2 molecule has 4 electrons in 2 degenerate pi molecular orbitals. C2 is actually 12 electrons, right? 4 electrons in its 2 degenerate pi orbital. Degenerate means of the same level. 12 minus this is actually 4 electrons here. So now here what will happen? 12 minus 4 is, 12 minus 8 is 4 electrons. So here it will be less than 12, that means 2, 1, 2, 1. So here what will happen? You will have 1, 2, 3, 4, right? So you will have, this is degenerate means same energy. So this is pi only. This is pi 2px. This is pi 2py. So it has 4 electron. That is also true. Helium, this is 1 electron. Hydrogen, this obviously hydrogen H2 has 2 electron. Minus 1 is 1 electron. So that is also true. This is diamagnetic. See, O2 is having 15 electron. That means odd. Odd is always para. So this is not dia. This is false. Okay, that's how you answer the questions within seconds from the tricks. Okay, if you don't solve it with the help of tricks, then obviously you will get stuck in the exam, right? Okay, now let's see, bacha, we are left with 2 more topics, that is dipole moment, and let's talk about this here. First is, let's talk about now 3 topics majorly we are left with. One is bond angle, then you have dipole moment, then you have hydrogen bonding. So these are very small 3 topics that we are left with. Okay. Let's see this. So bond angle, if you say, bond angle firstly depends upon the hybridization. So like we know in linear, bond angle is 180. For trigonal planar sp2 it is 120. Then for sp3 it is 109. Then further sp3d it is 120 and 90 as well. Now ma'am, why 120 and 90? Because between equatorial it is 120, but this and this will have 90-degree angle. Then octahedral has 90-degree, right? Then these are about other shapes. But you know, all you have to remember here is, don't go into this thing here. I would just advise you, just remember sp2, sp3 and sp3d. This. Okay. Linear, sp. Now out of this I can just write it here. Sp has maximum bond angle. Now, one thing always remember, more is the electronegativity, more will be the bond angle. Electronegativity means this sp has more electronegativity. So we know that sp is more, then sp2, then sp3. Okay. If hybridization is different, we can easily conclude what will be the bond angle. Now let's say the hybridization is same. If hybridization is same, then you will see bond angle will be inversely proportional to number of lone pair. More is the lone pair, less will be the bond angle. If both hybridization and number of lone pairs are same, then bond angle is directly proportional to electronegativity. If hybridization and lone pair both are same, then it depends upon the electronegativity of CMA. More is electronegativity, more is bond angle. If hybridization number, if all of them are same, even sentimental atom is same, then bond angle either depends directly on the size of surrounding atom or inversely on the electronegativity of surrounding atoms. Just remember this and you will be able to do the questions. Now if you see this over here, bond angle for the following compounds. Now the hybridization you should know first. CO2 has linear shape, so sp hybridization, this is sp3, this is also sp3, this is also sp3. So definitely CO2 is going to have the maximum. So let's remove this one. Now these three have the same hybridization. Now more is the lone pair, less is the bond angle. So here, if you see, this will be the least one here, because here the lone pairs are two lone pairs, right? So that is why this is going to be least. This is also eliminated from here, right? Now if you see this one and this one, the only difference is it has a lone pair here, and here instead of lone pair you have one more hydrogen atom here. So here lone pair, lone pair, bond pair, repulsion. Lone pair, bond pair, repulsion. Remember, lone pair, bond pair, repulsions are greater than bond pair, repulsions. That is why lone pair, bond pair, repulsion, this will have a little higher angle as compared to this one. Okay? So this will have a slightly more angle as compared to this one. So answer is going to be, wait a minute. Yeah. Bond pair na. Acha, this one is the lone pair na. Lone pair, bond pair, the angle will be more, yes. So if you see, this is the lone pair, right? Because of the lone pair, bond pair repulsions, here angle will decrease. So this NH3 is going to have less. Why I have crossed it, I don't know. I think by mistake I have crossed it. Yeah. Okay. So here, because of lone pair, bond pair repulsions, this angle here, this lone pair, bond pair repulsions will increase. So basically what will happen here, wait a minute, I think I lost it. Chalo koi na. Right? So if you see, this is nitrogen, this is lone pair, this is H, this is H, this is H. This will increase, this repulsions, and this angle will decrease. Right? This angle will squeeze. Right? So answer will be B is the correct answer here. Achha. Now let's talk about Drago's rule. Drago's rule, bacha, very simple. It directly says one thing, that if I talk about NH3, this is group number 15. Now we say when the hybridization is same, lone pairs are same, what it will be dependent upon? This will be dependent upon the electronegativity of central metal. Down the group, electronegativity is decreasing. That is why the angle should also decrease, right? Angle should also decrease, right? But what we saw here, the angle is 107 degrees, and suddenly it jumped to 93, then 90, then I think 92 something, 91, and suddenly it is decreasing. Now this, I am not writing the proper angles. This is approximately 93 something. This is 107. Now this jump is very sudden, decrease is there. High decrease is there. Now that we agree that if electronegativity is decreasing, this should decrease. But why this much large decrease? The reason behind this one is, I'll just, there is no, I'll just write it here only, right? Okay. See. And it is applied to group number 14, 15 and 16. And it is applied to second element. That means belonging to third element. Beyond second element, it will be applied. So why this? They are asking the reason why. Why there is high decrease? Reason here is because in this you have one lone pair. This is H, this is H, this is H. Here actually what has happened here, we know that in this you have NS to NP3, right? So this is ns2, this is np3. 1 2 3 4 5. If they became hybridized orbital, they will form this kind of situation. So it will be 1 2 3 4 and 5. This will be the lone pair, that is sp3. Now, in the case of nitrogen, this lone pair is sp3 hybridized. All these bonds are sp3. This is sp3. This is sp3. This is sp3. Okay. But in the case of phosphorus and beyond, it is not the case. This is a lone pair. This is H, this is H, and this is H. Now, what has happened? This will remain like this. This will remain like this. Okay. It remain like this only. This is NS, this is NP. I'll just write it as this is PX, PY, and PZ. So this bond is formed from PX, this from PY, and this from PZ, and this one is your uh, S orbital. You can say pure S orbital. This is one of the theory that explain this, right? So this is pure S orbital. That is why we are saying that in this case there is the electron negativity is less. Here electron negativity is more. That is why more electronegativity means more repulsions will be there. More repulsions means sudden decrease will be there. That is why this is 107 and suddenly it decreased to 90 degrees, because this is sp3 hybridized lone pair, this is pure S. Acha, one more thing here to observe is that here in sp3 hybridized orbitals, what you have here, now what is the cause, why this matters a lot? What is the consequence of this thing? The consequence is here it is sp3. We know that sp3 orbitals are, in case of electron negativity, sp3 is less electronegativity as compared to this. That means s orbital does not want to, if it is more clever, it does not want to give lone pair or donate lone pair. That is why if it does not want to donate lone pair, this wants to donate OMG. Oh my god, till when you had no voice? Oh my god, that is. Uh, 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 uh. Okay, dipole moment start. Okay, okay, I got it, I got it. Okay, just give me a second. Okay, 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 I'll just repeat it. Okay, so we were here. Here I just told you that this is sp3 hybridized. This is pure s orbital. Pure s orbital has more electronegativity, so it will be difficult for pure s orbital to donate. So it will be a poor base, and NH3 will be a better base. Okay, we talked about this thing in Drago's rule. Then I talked about dipole moment, which is a multiplication of charge and the distance. And here, when for any symmetrical molecule, mu net will be equals to 0, right? So we say always the dipole moment line goes from less electronegative to more electronegative, or atom to lone pair. Now here we said that here the angle is less, that is why dipole moment is more, because the resultant dipole moment will be more. Here the angle is more, that is why the resultant dipole moment is less. And here they are opposite to each other, that is why mu is equals to 0 here. Right? Acha, then we talked about that. Hey Bhagwan. Okay. Acha, now see. Now here I talked about that whenever you have angle 120 degree, right? Always resultant will be equal to other two things. So here this and this will form a resultant which will be same as these two things. So here they will form a resultant which is this, and it will cancel this. This one will cancel this. So here mu will be equals to 0. Similarly, here we have 120-degree angle. This is 120-degree angle. This is 120. Whenever the angle is 120 degree, here 120 degree, so it will form a resultant which is same, right? So it will cancel this, and here also mu is going to be 0. In other, mu is not 0 because it is not cancelling properly, perfectly, right? Okay. Now let's talk about the question here. The question says that identify the correct order of the property that is mentioned here, right? Let's talk about this correct order of property that is being mentioned. See, dipole moment, if you see in this case, you have water, one lone pair, this no cancellation will be there, है ना? Negative to positive, right? Then you will have atom to lone pair. Little bit cancelling will be there. Here you have lone pair, H, H, and H. This. Wait a minute. Okay, so here what will happen? This will eventually cancel each other, and here you will have CH, Cl3. Here if you see here, negative to positive, negative to positive, negative to positive, and this one is negative to positive here, right? And they are asking you the correct orders. Choose the correct answer in the given. Okay. This is slight cancellation is there, but here you can't see any cancellation here, right? Okay. Okay, now let's talk about number of lone pairs on the, let's talk about other things now. Okay, if you see here, okay, bond enthalpy is directly proportional. Okay, firstly I'll talk about this one. Here you had two lone pairs, that is why 4 5 6 5 6 7 8. This is 1 2 3 4 5 6 7 8, one lone pair, right? Because I need to make total 8 lone pairs. Okay, so here 4 are in sigma bond, 4 will be left. Here 6 are in the sigma and pi bond, 2 will be left. Here 2 are already there, and 8 minus 2 is 6. So 1 2 3 4 5 6. So here they are saying lone pairs, number of lone pairs on centimetal atom. Here it is 2, here it is 1, here it is 3. So this is not correct. Okay, this is absolutely not correct. If I talk about the bond length here, bond length here is oxygen and hydrogen. Here it is carbon and hydrogen. Here it is nitrogen and oxygen. Right? So bond length here, correct statements, B will not be correct here. So these two are eliminated here. So A definitely then will be the correct one here. I have to answer between C and D. Which of the following is correct? Right? So OH, then CH, then NO. Here the electron negativity is more, right? So here the order will be opposite. It should be CH, OH and NO, right? So this is also is not correct here, right? Let's see the D1, bond enthalpy. This has 14 electron, this has 16 electron, this has 2 electrons, okay? Here bond order is going to be 2. 2 by 2, that is 1, right? Here bond order is going to be for 16, for 14 it is 3, 15 it is 2.5. So it is going to be 2, it is going to be 3. So that is also correct. So A and D are the correct answers here. Okay, A and D are the correct. So you just have to look for the property, and according to that you can answer the question here, right? Now let's talk about the next one. Which of the following molecules have non-zero dipole moment? Non-zero, so this definitely is 0. Mu is definitely 0 here. We have discussed this. This is BF. This is like this. BF, F and F. So it is obviously 0. This is a linear structure CO2. This is also equals to 0. Right? In CCl4 also, all the bonds are like will cancel each other. Resultant will be formed that will cancel this. So this is also mu is equals to 0. So this is the only one where mu is non-equals to 0. So answer will be B is the correct answer here. Right? Okay, next question. Have I done it correctly? Yeah. Okay, let's talk about this one. Among the following in increasing order of solubilities in chloroform, right? So solubility definitely depends upon the polarized, like how much dipole moment is there, how much polarity is there. So if you see, since CH3 organic solvent, so covalent non-polar will be more soluble in it. As the dipole moment of solute increases, solubility in chloroform decreases. So more is the dipole moment, right? Less will be the solubility in the chloroform, because chloroform is an organic solvent. So we want covalent, non-polar compound here, right? So dipole moment, whenever it is increasing, solubility will decrease. Hence you can see we talk about this has mu is equals to 0, right? So that is why it has maximum solubility, and here maximum polarity is there, so it has minimum solubility here, right? So answer is going to be A is the correct answer here, right? Then the last one, guys, is hydrogen bonding. So we have two hydrogen bondings here. Like hydrogen bonding basically means that you have electronegative element that is connected to hydrogen, and it is further making a hydrogen bond with electronegative element. There is no sharing or transfer of electron here, right? So here intramolecular means within the molecule, like this hydrogen is forming hydrogen bonding with this oxygen, right? Inter means when one molecule is forming with other molecule, that is intermolecular hydrogen bonding, right? Now one question that was based on, I think this is the last, yeah, okay, so I'll just there is no need of this thing. right? Okay, let's see. The boiling, acha, this question actually is a mixture of this one and P block. If we talk about P block orders, right? Because here the boiling point of hydrides of group 16 they have written here. So yes, the boiling point of hydrides, if you see, the boiling points of hydrides of group 16 is of the order this. Yes, why? Because why? See, boiling point order uh, should increase as we go down the group. Actually, it should happen oxygen, sulfur, selenium, usse Dipole. Actually, what should happen? It should increase down the group. That means oxygen should have minimum. But why oxygen has maximum? Because of the hydrogen bond, this has a maximum. Because in water, it is forming hydrogen bond with the other water molecule. That is why the boiling point is maximum. That is the exception here. So this is true. On the basis of molecular mass, it is expected to have lower boiling point. That is correct, other than other members. But due to presence of extensive hydrogen bonding, it has the highest. It is supposed to be lowest, but this will not happen because of the hydrogen bonding. So both the statements are correct. And in fact, if they ask you assertion reasoning, this reason is the correct explanation of this assertion. Okay. And the last question is of nitrophenol in steam volatile where para-nitrophenol is not. See, ortho-nitrophenol has intramolecular hydrogen bonding. Because of that intramolecular hydrogen bonding, it is not able to form bonds with other molecules of the same thing. That is why it is not attracted towards, it is not forming any bond with other molecules. Itself it is forming the bond. That is why to break it, because it is not forming any bond, that is why with steam only it can form vapors, because there is no as such strong bond with other molecules. It has strong bonds with itself. That is why this is actually the true statement, because of intramolecular hydrogen bonding present in ortho-nitrophenol. That is the correct statement here. Okay. So that's it for today, guys. Now I will see you all in the next class, that is coordination chemistry, that may be on Saturday. Till then, bye bye, take care, see you all in the next class. Bye bye, and do let me know in the comment section, was the lecture good, how you liked it, and do you want more questions or less theory? Do write it down in the comment section. Bye bye.